You guys are really familiar with 1.2, and there we talked about things like horizontal auto-scaling for pods. Based on a workload, you can automatically scale the number of applications running. Familiar with it? All right, very cool. Automated rollouts and rollbacks. You've seen that with the rollout command and deployments. Services for persistent IPs and load balancing. So you get all of that out of the box. It works with monolithic applications or traditional applications, and it works with microservices-based applications. If you can package it in a container, and that can be a Docker container, and 1.3, that can be a Rocket container, then it can run on Kubernetes. So the base unit is a pod. You guys have seen this. So you have two containers that know how to play, or multiple containers that can play nicely. It could be one, it could be more. They share data volumes, they can all interact with it, and they have one IP. We use labels to select for grouping and hierarchy. So I could say I want all the version 1, and this would select anything with that selected. If I wanted just track stable, I would select just that one. And services and other concepts in Kubernetes use this. So service is a persistent IP. I have pods. Pods are short term. They can go down at any time. They're not guaranteed to have a persistent IP address. So if I have an application that I want to talk to, my back-end database, my front-end for clients to talk to, I can't rely on just the pod. Because if the pod goes down, it gets restarted, or I roll up, I might not have an IP address, which means no business, no money. So services can be external or internal, and they're just persistent endpoints. There's deployments, and deployment's job is actually scheduling the microservices or the pods on the machines. So if I have, in this example, I have 2, and I've declared up in the upper right corner that I want 1, so I'm fine, I have 2 machines to schedule on, everything is good. If I say I want 2, it'll double that for me automatically. If one goes down for whatever reason, it's in a machine went down, it would automatically reschedule it if I had space. So again, in that instance, the machine isn't as important, at least from the developer standpoint. What I care about is, do I have applications that run? And then once I do have applications in the wild, something's always going to come up. I'm going to have to update code for whatever reason. Maybe a new feature, maybe a security update. And we want a deployment story that's cautious. We want to cautiously roll out a new update. And if it works, then we're slowly wind down the rest. And we want to be able to instantly roll back if for whatever reason this update was bad. So that's all 1.2 stuff. We get all of that in 1.2 already, right? Or at least a lot of it. But what could be better? I heard persistent disk, persistent storage. I'm not remembering what else I heard off the top of my head. So if you want to shout something out, I'm in. Migrating. Draining, yeah.
Canary releases.
Canary. Well, so Canary you can do in 1.2 as well, just with the labels and deployments. So let's talk about 1.3. 1.3 has a lot, and I'm not going to be able to talk about all of it. So I'm going to focus on 3 or 4 that I think are the biggest ones, and then I'll send out an email to everyone else with like links or where they can find more information. So some of my favorites. Now there's a garbage collector coming in. It's an alpha. So basically, if you have resources that aren't being used, you don't want them spinning up. It's wasting time and money. So Kubernetes now has a way to go and clean those up for you. I like that I'm not locked into the Docker infrastructure anymore. I can use the Rocket container runtime. I don't know if anyone is ever going to, other than CoreOS, but you can. That's cool. There's been speed and performance improvements. So Kubernetes 1.2 had a SLA of up to 1,000 nodes, 1,000 machines, and you could get like 30,000 pods going, or 30,000 containers on a node. That was the guaranteed latency and performance up there. Is that blocking your picture?
No, I get it.
All right, I didn't shave today, so I had to get out of there. There's a few commands I like. Has anyone edited Kubernetes objects from a command line? Yeah? Normally it's kubectl apply, and you edit a file, or kubectl edit. I'll show you guys this in a sec. Now there's a set command, so it's just really easy and clean to go in. And the big features, init containers, fixing persistent disk. Does anyone use persistent volumes in 1.2? It's painful a little bit, right?
It was buggy.
You liked it?
It was buggy.
Oh, buggy, yeah. I was like, I didn't like it. Cluster federation is the big one. What's up?
So that's not really what you want to hear. Your data going buggy.
Yeah, so 1.2 is a little bit buggy, and now it's fixed. I'm happy about that. So cluster federation. This to me is the biggest, most exciting feature in Kubernetes 1.3. There's one centralized control plane where you can manage clusters or nodes of physical machines in whether they're in a GCP cloud provider or whether from on-prem, whether they're from AWS. And you can also have them across different regions and zones. So I can have something going up in Asia, something going up in US, and all replicated. So I can have a highly available system that's got redundancy set in. I don't know if you guys know Kelsey Hightower. He put out a 6-minute video actually going step by step through all this. So I can send you guys all the link. It goes really deeply into this. So you guys can try it out, set it up for yourselves. It's really cool. Next is jobs. Before we talked about pods. Pods are fungible. They could die, but we don't want them to. This is our application that's up. But what happens when there's one-off things we want to run? That's where jobs come in. So what a job allows us to do is it allows us to start up a pod or a container, an application, and run it to completion. So we can have 8 going, and we say, as soon as the first 3 get back, stop the rest. And this will take care of that for us. There's 3 types. There's non-parallel, there's fixed count parallel, and then there's parallel with a queue. So like messaging queue. So let's take a look at some of these.
So is that use case there just like an ad hoc job that you want to run?
Right, something you want to run off once. Maybe you're scraping data, one-time thing. A cron job would be an interesting use of this. Something you want to fire off one time.
Can you schedule?
Right now, they don't have scheduling built in. I think not in 1.3 yet. I don't want to tell you wrong though. So how does this look? It's very similar to a pod or a deployment spec. There's some new fields though, completions and parallelism. So we're saying how many pods we want to run at the same time. So here we want 2. And we're saying how many do we need to get it complete. So we're going to run 2 at a time until 8 of them return successfully. If a pod fails for some reason, we're just going to kick off another one. And you can see the restart policy. So this one's going to restart on failure. And is that big enough? Yeah, what's up?
Will you be introducing any ability to just fail after a single try?
Yeah, you can just change the restart policy to not be on failure.
Okay.
So you can say never.
Okay.
Mm-hmm.
Doesn't that
Yeah.
actually create new containers when you set it, the restart policy onto never?
No. So this is a job as opposed to a policy. But you're saying if this fails, when do I want to restart it? I'm saying never restart
We
it.
run jobs currently in 1.2 in the beta, and the biggest problem that we have is that there's no way to successfully exit unless you actually give a successful exit.
From my understanding, that never won't restart it. But I could check in a little bit deeper. So there's going to be a lot of questions, and some of them I might not be able to answer. Shoot me an email or hit me up on Twitter, whatever's easier for you. I'm Ask Carter at Google, and I'll go through next week and I'll go and like answer in depth. So next is init containers. I made a really cool animation, so let's check this out. That's it. All right, so how this works, before we had 2 containers running at the same time. Whenever containers start, they run at there's no ordering. There's no guarantee on when they're going to run. A lot of times you need things to happen before your container starts. So here I have 3 init containers. These are going to run in sequence. I'm going to run whatever was in container 1. It could be some kind of script. It could be a shell command. It could be an application that works with data. Then I'm going to run 2. Then I'm going to run 3. Once 3 is done, I'm going to start all the rest of the actual regular containers, just like a normal pod. So this can be really useful for things like populating a volume from a disk or registering a pod to an external service. So here we have on line 9, we're basically saying we're going to start our init container and we're going to make a post with some pod information to some external service. And I'll send out all these slides after, guys. So yeah. Where's Ariel? It's cool if I send out slides and stuff, Abner? Yeah, so no need. So then after that init container is running, that's when I'm going to start my regular container. But now that pod's been registered. And this gives us loose coupling because I don't have to change my application to hook up some kind of outside external service, but I can get it now out of the box. And I can reuse that in other places. Here we're gonna, so volumes are shared data. Anything inside of a container or anything inside of a pod can share this data amount. So here I'm gonna run a container that's cloning Git into some location. And then when my regular container starts up, it can use that. So you get a lot of power and flexibility. I don't know if there's a limit to how many of these you can run. If one of these fails, so if I had 2 init containers and the first one failed, the pod wouldn't start. Or if the second one failed, the pod wouldn't start. All of them have to pass before the regular container starts up. Next, some people were asking about persistent data. Well, that's where pet sets come in. One, persistent data, the mounting and unmounting problem has been fixed before. In 1.2, there was an issue where if a pod died, got restarted, it wouldn't unmount the data, and then you couldn't remount it. So that got fixed. But on top of that, we've added these things called pet sets. And basically what we're saying is, if you have some database service or something going on, it's not stateless. There's times where your application needs state, and that's what pet sets are. So you guys heard the pets versus cattle analogy? All right, so if you have cattle, you don't care, you just make hamburgers out of them. If you have pets, you love them and take care of them and give them names. So that's what these are. They're pods with ego. We're going to have a stable host name, so like a service connected to it. We're going to have a unique name so we can always reach them and access them. In the future, after 1.3, they're even going to know which one they are out of the set, so it might know that I'm pet number 1. And then they have stable storage. Yeah.
What happened if the node failed?
The node failed. So now that persistent volumes are fixed, that would die, restart with the same name and stuff. It's a persistent endpoint, but it would rehook up the data. So just like with the service, you could say my backend service, and you can always reach it, even though behind the scenes maybe the pods change. It's really similar to pet sets, where rehook up to the same data, still have that same endpoint.
That persistent storage physical to local, or can it be remote, like NFAs, registries, something like that?
Both. So I'm not 100% sure on the local story. I think it's one node, last I checked. But yes, there's a network just like persistent volume. So I could say AWS disk, a GCE disk.
What's the target use case? Is this for something like Cassandra nodes or some other database?
Databases is probably the biggest use case. So maybe I have my SQL database. I want to interact with it, but I don't want to do that manually. But I do care about that stateful pod. If it goes down, I want it to come back up with that same data. So that's the use case.
Can I add dynamically resources to those containers?
So what you have is a persistent volume claim. So when you say dynamically, can I use it at runtime and add data to it?
Compute, CPU, memory.
Yeah, so it's just like a data volume. So this is a really small slide, but what's happening is basically I have a volume claim, which is saying I have a database somewhere. It could be localhost, it could be networked. Mount that to my file system, so I could say mount that to my desktop or home, and then I can read and write to it just like a normal disk. Now, when this dies down, it's going to rehook it back up. So I've used GCE, so I made a GCE persistent disk and then mounted that. It could be any of the supported disks.
Yeah, what I'm thinking is before it dies, sometimes I have a monitoring tool, like let's say it reaches 90% CV utilization or whatever.
Mm-hmm.
And now when I add dynamically without moving it so it doesn't die, can I still do that?
Yeah, so that's the goal of pet sets, is so that you still have that data available and it doesn't die. As opposed to if you just had a pod.
So it seems like you could automatically resize, like you can say if this gets to 90%.
Oh, that's what you're asking.
Yeah.
Thank you for clarifying. So it's asking if you can resize the disk dynamically. No, not that I know of.
Or compute, memory, CPU.
So you can re-dynamically size nodes. You can say I want more nodes to run on, but the actual data disk, you have to size that manually from my understanding. So I have to go in and say I want a 10 gigabyte disk or a 100 gigabyte disk. Even if it reaches that threshold, I can't say give me another disk. Now, we have an abstraction called volume claims. So I don't know if you can see it on here. I have what's called a volume claim template. Basically, instead of saying specifically what disk I'm talking to, there's a layer of indirection. So I say I want this claim, but I can have different backends to that. It's kind of hard to explain, but
So if you have like an LVM backed volume, could you dynamically resize that?
I'm not familiar with LVM. So, but I don't know about dynamically resizing. To my knowledge, you have to go and manually switch out the volume. Now, claims or volume claims in the future should be able to do a lot more of this, which is why they added that indirection. But I don't want to tell you can if you can't. So with pet sets, remember you have that you have a DNS entry. You have a stable IP address. So this is the other part. Basically, what we're doing in the last slide, I said I have a service. It's on. Service name line 6. I had to highlight it. On the next slide, this is the service. And so all I'm creating is a service that isn't externally available. It's called a headless service, and it's opened up. So that's basically what a pet set is. It's a pod that has some kind of persistent data. It has a unique name, and it has a stable endpoint. Oh, cool. So what I talked about so far was Kubernetes by itself. There's managed platforms for that. I think Ariel was talking about that. There's also Google Container Engine, which adds a lot too, like cluster auto-scaling. So if I had 10 versions of my application running, and they were filling out my machine, I didn't have enough space to keep running, I can automatically dynamically load up. Am I in the way of that picture? All right.
Slides.
Yeah, I'll send them out. There's IAM support, which is access and roles. 1.3 actually added role-based access, and they had a different type. Local SSD support you get with GKE, so I can have a local data disk that's pretty fast. Container VM images are supposed to be a lot more secure. That's in beta. So when you make a disk, you can say I want this to be a container VM disk. And node pools are like a lightweight version of cluster federation. I can double data up.
Can you like the container VM images? I'm sure they
Yeah, so what a container VM image is it's a disk that has a little bit more security. It's for use as a container. It's supposed to be running containers. And so those are rolling out now. They're just more secure VMs. And we're just assuming that the use case is, you're going to be running containers. And what node pools are is if I have a database application, so I might have a few layers. I might have a database layer. That's going to sit on maybe 100 gigabyte machine, a much larger machine. But my actual front-end UI and stuff like that could be a smaller machine. So node pools let you have different size disks in the same cluster. And then you can also replicate that across zones. So some things I found that I liked. There's this thing called MiniQ that just came out. And it's basically an easy way to start a local machine. So here's one of my coworkers playing around with it. Basically, you just use the same kubectl run. Once you start MiniQ, then it'll connect you automatically and it'll set up that for you. So it's like GKE, but locally. I thought that was really cool. And again, I'll send that out in the slides. CubeUI is cool. It got improved. I'll just show it actually. Is that a good size? Yes. All right. Let me see if I have anything. Okay, so our creative deployment right quick. Here I'm just using a Docker image, and this is something I created before. All right, so now I have a deployment. Let me take a look at it. I'm gonna scale that. All right, so you guys have seen the basic happy path through Kubernetes, right? Is there anyone that wants me to talk about that a little bit more? Yeah, oh, okay, I'll do that. You saw a deployment before, it just manages versions of your application. So right now I said I want one version of this application. So if one were to die for whatever reason, so our applications are pods. If this were to die, like maybe someone like me went and deleted it, it's going to restart that for me automatically. So now if I say get pods, you'll see that a different one was created. On the other hand, I can do things like scale deployments pretty easily. So, I have more load. Maybe I want, 7. Now it's pretty easy to have, 7 versions of my application running. And then the very last thing is I've already set up a service, and so I can just load balance traffic to that. So this is just like the basic 1.2 stuff. So here I could say something like curl, and I'm talking to my application. So some of the power comes in when I do things like, here I'm going to edit that file and I'm going to change what's running. And I'm going to say that I want a different version of my application. I'm going to use a rolling update. And now if I curl that, sometimes I'm going to get hello, and as I keep doing it, I'm going to start getting more goodbyes. I'm gradually getting a new version of my application. And if anything were to go wrong, I'm just going to take a look at this for a second. You can see that I have 2 versions of my application. I have the one I started off with scale, and then I deployed that file, so I got a second version, and I can just as easily roll back. So I could say undo that. If I were to look at the history, you can see I kind of switched things up now. And if I were to curl at my endpoints, I'm back to my first version of that. So that's just 1.2 stuff. Now what's interesting is they've added a front-end API, or UI. It's very similar to the one they had in 1.2, except it's been updated to cover like my, actually this is my service. So you can see that my service automatically picked up 7 pods behind the scene. I can go and look at these pods and find out more information about them. Even what nodes they're on, what machines they're on, labels they have, what version of the image they're running. And I can see the rest of the objects running in my world. So one of the things that's interesting is you see I have 2 replica sets. One of these is the old version, version 2. One is the version 1, and that's what allowed me to roll back so quickly. So I can also do things like deploy an application. Test, let's see. Pods 3, service, external. There's advanced objects. I'm not really going to use them, but I could add labels. So, and there's also things that are really cool from 1.2 is like limits. So I could say, don't let this take more than half of my CPU on any machine, or only schedule this onto machines that have at least 20% CPU. So you get a lot of power right away. So if I deploy that.
And can you see the compute power?
The compute power?
Like when you deploy from UI, can you see this deploy configuration from UI?
Oh, so this created a replication controller, and yeah, I can check that out. Can I check that out from the command line, you're saying?
Yeah.
Yeah. So if I were to say kubectl get rc, you'll see it there. So I could have created it from here too. Now some of the other power comes, I like the command line personally. I can scale that up from here. I can edit the objects and edit in YAML. So yeah, that's the UI they've added. What else? I learned something really cool making this talk. I didn't know this, so I kind of wanted to show you guys. I don't know where I'm at. All right. If you type kubectl explain, you can get a definition for every type in Kubernetes. So a pod is a collection of containers that can run on a host. This resource is created by clients and scheduled on a host. But what I found out is you can keep going. So I said pods.spec, and then that gives me all of the fields I can put in my YAML. And then I could even go deeper and say like pod.spec.say restart policy or security context. So kubectl explain is a really good way to find out what you can have on your pods and what you can't. All right, so to recap, there's 3 major hurdles with applications. The application itself. So do I want a microservice? Do I want a monolithic app? What are the trade-offs of that? What's the complexity? Can I use that with my framework? Is the best practice to say, wrap things up in containers. If I do use containers, am I using Docker? Am I using something else? Am I locked in? Do I have flexibility? What about security? There's the infrastructure that goes along with handling these things at scale. So if I wasn't using this kind of framework, scaling my application up would have been really difficult. But here it's just a command line. Even better, it happens automatically. I'm not manually typing this, and if I were to delete something or a machine goes down, Kubernetes notices that and reschedules them for me. Same with service discovery and networking. It handled all of that for me. So that's the infrastructure. There's more that we didn't talk about, but I'm sure you guys have seen, like secrets and configuration data. There's a lot of complexity that comes with scalable applications. So you want a framework that can handle that complexity. And then finally, thank you, Docker. I like it. It just sensed it. It was like, oh, they're talking about Kubernetes right now. And then there's the wild. And basically that's production needs, maybe you have data that can't live on the same physical machines for government rules, government law. Maybe you want to have a high available system, so you need to replicate data. And no matter what you do, if you write code, you're going to have to update it at some point. So you need a story to do that. You saw rolling updates here, which is a really quick way to push out code or fall back. There's also canary deployments that you can do pretty easily with replication controllers and labels. Blue-green deployments are another pattern in that space. Now, some of the claims were planet scale. You can never outgrow Kubernetes, and it's something that you want to be able to run anywhere. With the features they've added in 1.3, I think they've gotten a lot closer to that. In 1.2, you could still run Kubernetes on AWS or on-prem, but now you can run it on AWS and on-prem, or GCP and AWS. So I think you have a lot more power there now. With MiniQ, it's a lot easier to start up a small local cluster. And the reason I haven't shown a lot of these things is 1.3 didn't release yet. It's releasing later this week. So I don't have access to it from this show. And then lastly, planet scale. They've had a lot of improvements with speed and scale. So before the SLA was 1,000 nodes, 1,000 VMs, which is big. And now it's supposed to go somewhere between 2,000 and 5,000. So I missed a bullet there. Lastly, some people were talking about training. I put out a course with Kelsey Hightower on, I'm just going to play the video. I can explain it better than I can. I don't know if there's sound actually, so I'm not going to play the video. But basically, we put out a Udacity course that you can find.
It should play sound.
Huh?
It should play sound.
Oh, yeah?
Might have to turn the volume up on it.
You guys are going to hear my silky baritone. No.
On the TV, you might need to turn the volume up.
Gotcha.
The remote was up there somewhere.
That's all right. So we put out this course so that people could basically train with experts on their own. It's a free course through Udacity and Google, going over the basics of Kubernetes. The services, the deployments, the pods. We glossed over it here because you guys are pretty technically in depth. But we also go over things like
Kubernetes. These are a few of the hottest buzzwords in scalable computing today. But what's driving the hype? In the last decade, user demand for always-on applications have grown exponentially. Users expect their favorite sites and favorite services to be up 24/7, no exceptions. Many developers have focused on application patterns such as microservices to meet this need. But what about the infrastructure needed to support these always-on apps? This course from Google Udacity is going to show you step by step from theory to production how to meet and exceed these demands using tools that are available today. Learn from industry experts like Google's Kelsey Hightower and the former cloud architect of Netflix, Adrian Cockcroft, about modern application design, best practices for using Docker to package and distribute containers, and how to manage deployments and scale applications with Kubernetes. So what are you waiting for? If you want practical, hands-on advice for containerizing your app and managing it at scale, sign up today.
So that's a free course that'll go over the basics today. So it won't go over like cluster federation. Although I'll be sending out a video that Kelsey did where he goes step by step through it. So it's kind of like a continuation. But yeah, let's see. So thank you. Check out the blog for the big release. So that should be next week. 1.3 should come out. And they detail a lot more of the features. This was just an overview of what to expect and where to look for more. And then I'll follow up with everybody here and send out an email with the slides and notes underneath them and links. So one last thing. I feel like people are going to ask me about Docker and Swarm and what I think about it. Is anyone going to ask me that?
Sure.
Okay. I saw like 7 heads ago. I was going to get you. I think it's great. It's great for users. If anyone's seen Swarm, it looks the new Swarm release. It looks pretty similar to some of the Kubernetes concepts. That's because Kubernetes has proven concepts. So I think it's good for users. I think you should go out and experiment and try different frameworks. I think in the end you end up with Kubernetes just because it's a little further along. It's general release, it's production ready. But I think it's good for users that are adopting these container-based technologies and these different paradigms around how to orchestrate containers. All right, so questions?
Now that you mentioned that, how do you think Kubernetes and Kubernetes from Docker?
How do I think Kubernetes is what?
How do you think Kubernetes is pieces which I provided now in Docker, like so Kubernetes also from Docker, like data orchestration?
Yeah. So how does Kubernetes build on that, or how does it fit into that world?
How does Kubernetes go beyond what Docker?
Oh.
provides?
Well, things like cluster federation, things like security, and we have secrets and tokens. So we have ways that a lot of people bake in passwords into their Docker images, which is really bad practice. Even more people just leave passwords up on GitHub. So Kubernetes gives you these abstractions to have someone manually load a secret, but it doesn't live inside of the container. So it's a lot safer there. What else? The story for persistent storage is a lot smoother, I think. And then some of the abstractions are a little more battle tested. So Docker Swarm just announced their version of pods and services and things like that. They call them dabs, and I'm not sure what they call their services. And they're similar, but I think Kubernetes has been just stressed a lot more. Also, Kubernetes has been used by a lot of companies, so we have companies using our stuff up to 1,000 nodes. Kubernetes is used by Azure. It's used by other big companies, and Google as well. So I think that's where the benefit comes in. When you have things that can't go down, you want to use Kubernetes. When you have demos and things you want to run, try other stuff out.
So you brought up Google.
Google.
It's my understanding that Google runs their containers inside of KVM.
I actually don't know.
Yeah.
So that's a yeah?
It's public.
You know why?
I don't know.
So
I know that.
I know internally we use a system called Board for orchestrating our containers. And that's what Kubernetes is based on. So Kubernetes is only a year old. I think its birthday is coming up.
Is that it?
Yeah, it's a year since it's been
In the
1.0.
middle.
Yeah. But
21st.
the 21st is the birthday?
We'll be having a meetup with the Core OS folks.
Oh, awesome.
We'll be for that. We'll have a party, barbecue. I'll be announcing on that.
And CoreOS just added a lot of security features to Kubernetes 1.3. So a lot of that role-based access, and I forget the other word, but it's ADAC. They added all that in themselves. Any other questions? What we got?
So, in terms of replication and scalability, scale up or scale down,
besides the system metrics, also
User
application
defined.
triggers?
Yeah, so you can actually use user defined through annotations on your pods. So you guys saw how we had labels. Labels are just arbitrary key value pairs. Annotations are very similar, and we can use those to pass into an external tool like Keystore to say
Which one?
Keystore. So that's the one Google Cloud, Google Container Engine uses by default. So when you start up a GKE cluster, it has Keystore turned on, it has a stack driver turned on for you. But you can add annotations that say things like, what is my, like how much of my CPU am I using on this pod? And you post that as a label, Keystore will look at that, and then it'll restart your pods or scale them up based on that information.
Is that, in terms of infrastructure support, is that only limited to Google Cloud or other infrastructure?
Dev infrastructure, what do you mean?
And in terms of AWS, like is there a filter there? Where if your Kubernetes cluster is on AWS, for example, right?
Mhm.
So have to set up Keystore and just go with it, in a sense? Because he said that he would define.
Oh yeah, so that's outside of Google Cloud. It doesn't matter what cloud platform you're from for Keystore.
So I think the question was how to scale it, right? But,
Yeah.
So I think the question was how to scale. Let's say I have 3 workers.
Mhm.
I want to add on runtime 10 more
Yeah.
in case of my custom logic, not CPU or memory.
Yeah, totally. So that's outside of the cloud provider, and that's the big goal of Kubernetes. It wants to be cloud agnostic. So obviously Google's very invested in that, but whether you're running on AWS or Azure, the same mechanics for the most part work. There's a few that are slightly different, like persistent disk. They look a little bit different depending on if you're doing it on AWS or on GCP, because you have a physical machine there. But for scaling and those higher level abstractions, you generally don't have to think about the machine. So if they work on one, they should work on the other. The only big difference to that is on-prem. So if you're not using one of the big cloud providers, and I actually don't know a lot about on-prem, I haven't implemented that before, so but I think that's a little bit different. Because when you're using a cloud provider, you get their load balancer. So if I'm running on AWS, I get the AWS load balancer, the Elastic load balancer, whatever it's called. If I'm on GCP, I get the Google Cloud load balancer. And so on-prem, you have to provide your own, I think.
So that was actually my question,
Yeah.
what the value proposition of running Kubernetes on AWS. Like, I understand doing it on-prem or on infra because I can add labels for things like racks, so it would be rackware or J or PDUs or whatever.
But you can do that for AWS or GCP as well.
And it understands all the availability zones and whatnot.
Yeah, so basically when you have like a node or something like that, so here I use Kubernetes, kubectl. Good. I just mixed 2 commands in my head. All right, so here's my actual machines. And if I say show labels, you can see that I've marked these with arbitrary things like the zones. This is actually Kubernetes handled this for me, but I can add labels myself. So I might add a label to this machine, ZEWN.
If you start a Kubernetes cluster across multiple availability zones in AWS, and you have persistent disk, it will make sure that it only schedules the service for the pods on the zone that has, or on the nodes that are in the zone that has the EPS.
Alright, that's,
Yeah, so you can also use node selectors.
It will
So-
also prefer to schedule pods across multiple availability zones. Because you only get the SLA if you schedule
if you do
across
that.
2 availability zones.
And so here you can see I added that enable. So what I could do is I could create a pod that was specifically looking for that label if I wanted to. If I only wanted to schedule, I could say select the node with that label. So I could select the labels with zones, I could say size or anything like that. So the big benefit of Kubernetes, and other orchestrators have this too now, is that it's declarative for the most part. I can write in a file and say this is the state I want, and it's going to work to kind of make sure the system matches up with my desired state.
So are people managing their AWS infrastructure almost exclusively with Kubernetes?
I can't answer that one. I don't know.
So actually what happened is,
You are.
CoreOS actually released the AWS tool, and you can spin up a whole cluster in AWS with that tool. And that's kind of outside of Kubernetes.
Yeah.
And you get basically you get a Kubernetes cluster almost native to AWS. It feels pretty good. But of course, it's not,
Mature.
I mean, I think it works well. It's just you don't get all the benefits. But you can use all the things you mentioned. You get also the network, so you can basically use all the nice features of the AWS networking, and it works on Kubernetes, or it works in CoreOS. So it's not using the AWS base Linux image.
Rudy, can I throw you under the bus a little?
Sure.
Yeah. So Rudy's a former Googler. He works at a company called Verify. They do artificial intelligence, like the image recognition stuff, and yeah, he's using Kubernetes and Amazon in production.
We've been trying to move away from VMs.
Yeah.
and containers.
What do you think about serverless?
It's stuff like RDS on the children.
Yeah.
But you're managing it with majority
Yeah, we're,
via Kubernetes.
yeah.
We are doing it in production.
Oh yeah.
Yeah.
So AWS and GCP have some licensing things, so I'm not allowed to play with containers on AWS. So I haven't been able to try it out. So I'm glad you guys are here.
Yeah, I mean, basically CoreOS is filling that gap because AWS built their own container engine, and CoreOS is basically putting, they're filling that gap. That's it. And
Right.
you can use their tools to basically spin it up and run Kubernetes if you want to.
Right, and in fact, some of the literature I read about 1.3 was from CoreOS.
Oh, good.
And spinning it up on Azure or AWS or GCP.
Yeah.
Are you talking about
So shameless self. If you would go ahead and check out stackpoint.io if you want to just spin it up on AWS, Data, Sugar Packet, and again, it's 3 clicks. I'll demo it after we're done.
Now, one of the other things I really like about Kubernetes too is this idea that you have namespaces. So you can separate out resources by say, I want something that's test, or I want something that's production. I want 20% of my resources or CPU to go to test, and the rest to go to production. I'm going to have a certain set of secrets or keys that are in this namespace or the other one, and I won't see anything that's in any of the other namespaces.
How do you securely distribute those secrets? Like, I think tokens are great, but if they're going over the wire, then
Right. So creating a secret, so it's a manual process as far as I know. So I might, let me see what I have on my disk right now. So one thing in 1.3 is coming out is you can make a secret out of a key, out of a PEM, like so assert in a key.pem. That's pretty cool. It's for testing mostly, not for production. But it's really quick now to set up like a ingress load balancer, like an Nginx type thing, with a self-signed key.
Are you embracing any vault solution?
Pardon?
Are you embracing any vault solution, like HashiCorp vault?
Oh, I don't know much about Vault, sorry.
So you're not providing in the ecosystem any.
Oh, not that I know, not like a
Just
Keystore.
secret for you.
Yeah, so we don't provide a Keystore or like a signing authority.
It's all stored in that CD.
Yeah, on the masters.
So
Yeah.
that's my other question. At CD v3,
Mm-hmm.
how are you gonna support as a full federation with, and are you extending also etcd with the federation? So can we view it as a pool to etcd?
Well, so basically you have separate clusters, and each cluster doesn't have an etcd with it because they have a separate master.
But we provide a common view of all those.
Yeah, so you have one control pane where you can see everything. It's called the master, I think. I don't know.
etcd is great to store other things. And we can read with Nginx and other tools, as concepts.
Mhm.
So it's a great feature. Just wondering what else you added to it.
Oh, I don't know much about that. If they're adding
Yeah,
stuff,
so that's actually not part of Kubernetes. You have to actually manage etcd yourself.
and you can plug in console if you want to. Most people go with etcd. But.
Sky DNS actually runs its own etcd server, separate from the main etcd server.
Yeah, so
I
actually
forgot what I was
we
gonna
do is
show.
We have etcd, we're running Kubernetes on it, and we use all the application reach out to that same cluster.
So I know the opaque secrets are stored in plain text in etcd, or these keys that you're storing, are they actually encrypted in some way? Or are they
No, they're like base 64,
okay.
so it's not a strong encryption.
Okay.
And from my understanding, that is one thing that Docker might do better, is they have SSL or TLS communication between their master and their client.
You can do that in Kubernetes.
Yeah.
You can set up, but I mean they have that just by default.
Yeah, with the CoreOS default setup for AWS Kubernetes is TLS.
Oh, nice.
Sets up all the keys.
So all the
and
communication
all
between.
the workers, yeah, all the workers talk.
Just storing the keys, that's the problem. If we do a security audit, first thing is ask where you keep the keys.
Mhm.
Do you have a vault? So then we need to dance around.
I mean, it's up to you. If you want to, you can actually secure it. So you deploy your application with some kind of key, and then you decrypt the key if you want to. If you want more security.
Does Cluster Federation replace Kubernetes, which is something they mentioned?
It's the same. We've just been calling it Cluster Federation now that it's official. It's the same.
And can you move a workload from one cluster to another? So if you've got two data centers running two separate Kubernetes clusters, and one, for example, fails, can that control plane shift workloads to the other?
That's a good question. Shoot me an email and I'll answer that one. I'll send it out to everyone because I don't know the answer off the top of my head.
Can you spawn deployment models?
Can you what?
Deployment models, spawn across, like I want 20% in Singapore, 30% in Europe.
So what you do is you set the context when you're, so if you're manually typing this command in, you would set the context. And that context is the zone or the region. So you'd say you basically deploy things there. So I'd say I want in Asia, I want to deploy 6. So you don't split it like that. Did I miss someone? I was going to show something, but I forgot what it was, so I'm not going to show it now. Are there any other questions?
When does it come out? Next week?
It should, yeah, for the birthday.
If Kubernetes master node fails, would they elect to have a node?
No, no. That's not my understanding.
So the pods will continue to work, but I won't be able to deploy new one of these keys, right?
You have to start up a new master.
I'm sure it's in the cluster up still in the United States.
You can sell multiple masters and it will actually.
Actually,
Yeah,
you only have to keep one cube left, and once that is running, it will bring up the whole, like all the pieces.
Because SCD is backed up or does it have it on?
So I'd say it has to run always, of course, but the kubelet is actually that's running the containers. And if you have one kubelet, then it's going to bring up the master if you set it up that way.
Multi-masters work really well.
It works.
Yeah.
Is that something people are doing in production?
Yeah,
Multi-master?
1.2 already.
Oh, that's awesome.
You just put a load balancer on
Over the server.
Yeah, it again use SSL. It's safer that way, but works.
So you put like AJ proxy in
Use Amazon CLD. So you like
Oh,
Amazon.
Amazon, yeah, right.
You know, Kubernetes works outside of x86 architecture, and I take or PowerPC or
Yeah, so people are running it with like Raspberry Pis, the actual machines, no, yeah.
And if I'm missing an architecture there and I want to hide that to that architecture, is there an easy way to do that?
I've never done it, so I don't know. I can't.
Go complies with that. Go complies to that.
There are some guys who use cluster on the Raspberry Pi. There is some demo in
I mean,
Yeah.
I get it upstream so that every night when new Kubernetes builds gets in, I can tie into new CI pipeline architecture that will compile to it.
Most part is on the scope. Should be good.
I think that's it.
That's it?
Just one more question.
Oh, yeah.
For the auto scaling,
Yeah, which one? Vertical?
if I
So with your application, you have three levels, right? So you have some applications that you say, this is the most we're ever going to use. Some you don't set that top limit, and then some you don't specify anything, right? So we call them burstable, guaranteed, and another name. So if you resize a disk, that means you took that disk down and you have another disk that's bigger sitting there. So Kubernetes are scheduled to fill that up. So if you say, so now if you have a pod that you didn't specify an upper limit, a max, it'll use as much as it can on the machine.
I do the same thing for memory and processor.
Yeah. Yeah, so you specify CPU and RAM. I think that's
is more flexible. Is if you run Kubernetes on top of Mesos, the map more flexible stuff besides allocating like resources.
And now with GKE, now you're going to get node autoscale. So actual machines, you can say, if you had 2 machines to start off with, you scaled up 100 of your app. You can say, I want to scale up to max, making 10 applications, or 10 nodes. By default, in Kubernetes, even 1.2, you have pod autoscaling, which is you can specify either by CPU, built in, or using like Keystore external monitoring that I want my application to scale up or down based on some workload.
Considering cluster autoscaling works in GKE, I assume that if you're rolling your own on GCE, that gets exposed. So you consider it for some.
I don't want to tell you wrong. I have to, let me look into that. Yeah, let me look into that, because I'm not sure what they're doing.
So I'm kind of doing ad hoc right now, it's a little funny.
Oh, yeah?
Well, just because it's not the actual equivalent to Kubernetes.
How are you monitoring?
Heaps are different folks.
Okay, very cool. Yeah, so I couldn't answer all of the questions. This is really new, so I haven't got to play around with it to the level I normally would. So send me your questions on askcarter@google.com, or if Twitter's easier, I'm _askcarter. And I'll go through next week and start answering questions. Before then, I'll send out the slides. There have all the links to things I talked about today, like MiniQ, Kelsey's Cluster Federation video, so if you want to run through that step by step, he has a whole lab and stuff set up. It's a 6-minute video.
Will it be a new course or additional?
It's just a video on YouTube.
Additional video? Just on YouTube.
Yeah, and he has the code on GitHub. And then same for the Udacity course. That's mostly, we have it all up on GitHub and stuff too. Just want to walk through 1.2's features. So if you still need to understand 1.2, that's probably the best way to learn it. Cool. Thanks for having me, guys. Thank you.
All right. A lot of you have AWS questions. I know we got Rudy over here, but I encourage you, Dave, I know Dave probably wants to go home and go to sleep at some point. So the Java guys, if you want to go talk to him and entertain him and buy the rest of us a little bit of time to hang out, I encourage you to mingle. We have the space. If you want, I'll show you. We're going to spin up, I have a version up on staging. I'll spin up a quick cluster on DO because it's the fastest, DigitalOcean, and we can run days on it if you want to take a look at what StackPoint Cloud does. But thank you so much for coming out, man, and appreciate it. Thank you all for coming. Oh, July 13th. I'm going to make it live in a little bit. We're going to be back here. Dave will have us. And again, we're going to have Barack, who's the lead engineer on Taurus here. We're going to have the CTO from Tigera. I'm probably not pronouncing it that right. And then on the 21st, we're having a joint meetup with CoreOS. It's going to be barbecue. There's not going to be a lot of talking. There's drinking, both alcoholic, non-alcoholic beverages, and some food. So thank you. Thanks, thank you so much for coming. And I hope come back out.
I would love to. I wish I was here for the barbecue.
Oh, I'm sure you guys in Seattle are going to do something.
Yeah.
How long have you been out in Seattle now?
I've been there for 5-6 years. But
okay.
Yeah. That was a lot of fun because it's so new that there's a lot of questions I just haven't got.
Yeah.
He runs now. Yeah, he's here.